Hi, I'm planning to demonstrate the procedure to develop ANSYS ACT applications using C# programming. I assume that you are already familiar with developing ANSYS ACT apps using Python programming. Typically, if we want to develop an ACT application using Python programming, we need an XML file to define GUI components and a Python file to define actions when we click a button on GUI. Though not many analysts prefer to do programming, it's always good to learn some programming languages to a certain extent so that we can automate many of the analysis tasks to increase the productivity. So there are many ways apart from Python to create an ACT app. Let's look at what are the different ways to customize. Always help documentation is a good place to get started with. Let's go on customization shoot reference ACT developers guide. Here is the place where we can find out the information about advanced programming using C#. It's not only about the C#, we can use also the other languages that can create .NET assemblies. There are some advantages and disadvantages of using C# over and Python. Probably you can do a Google search to understand the pros and cons of C# over Python. So the typical way to develop ACT using Python is to have a XML file and a direct py file. But using C# approach, we have a XML which is same as that of a Python approach. This is going to define the GUI components. But we may not be able to use the C# file directly to build a ACT app. So we need to have a DLL file generated using the C# program through Visual Studio compiler. So this C# file is the place where you write the programming, and we will use Visual Studio to compile and generate the DLL file. It's important that we use a compatible version of Visual Studio to compile and generate the DLL. I'm going to demonstrate today example using ANSYS version 18. Let's look at the compatible version of Visual Studio for version 18 of ANSYS. So to find out the compatible version of Visual Studio compiler, go into installation and licensing guide, installation and licensing documentation, get into Windows. I assume you are going to work on a Windows platform. Then the platform details, you will find a session for compiler requirements. So we are going to work on a mechanical workbench interface. So we need Visual Studio 2012, which is a compatible version. When the version of Visual Studio other than what is used to build a specific version of ANSYS is used, it may work or may not work. So however, it's highly recommended to use a compatible version of Visual Studio while compiling the C# code into DLL. To get started with an actual example, I'm going to use one of the example given in the help documentation. Let's start with this example. So here is the XML code which is going to define the GUI, and here is the actual C# code. I'm not an expert in C# programming as such. I spent a couple of hours on Google to understand the basic syntax of C#. Probably we are going to use the existing examples and modify for our various requirements. So it's not that you need to be an expert on C#, as long as you understand some basic syntax and the working principles, that should be enough. To get started with, let's create an XML file. I'm using a Notepad ++ so that the syntax highlighter is good. I'm going to save this in a place called ACT C#. This is my example one, so I'm going to name this as C#. So this should be same as this, CSharp. The naming convention of this XML file is same as that of building an ACT app using Python programming. So I save this here. Let's go to that place. Example one, this is the XML file. We need to have a corresponding folder where we are going to keep the DLL and the image files. So we are going to call some image file here. So let me create a folder called image. Parallelly, let me create some image here. I'll just take some of the example image that I have. Let me copy this into image folder here. The file name given for here is called tload, so I'm going to rename this image as tload here. So now we have the image file ready. The next task is to get the C# code and compile that. So as we have seen, we have to use Visual Studio 2012 to be compatible with ANSYS version 18.0. So let's start a new project. This is going to be a Visual C#, and we are going to build a class library. The name can be C#, and create that. You need to follow the same naming convention as per the requirement of C# programming. Okay, let's say project one. Alright, so this is the default programming syntax. Probably inside that we are going to fill. For time being, I'm just going to copy this into another empty file, and I'm going to bring the C# code given in the ANSYS help manual. Let's bring that here. Right, so this is the C# code. Let's look at what this code is trying to do from the XML point of view. So this XML is going to create two custom objects. One is for load and another is for result. When we look at this example, the XML file is same for creating load and result. but the C# code is different for a load object and it's different for the result object. So in this example, I'm going to pay attention only on the custom load. Later you can use the same approach for a custom result as well. Okay, let's save this project. Now these are called reference libraries. Something are already predefined, we could use that. The system.text, system.collection, or generic libraries which will get loaded by default for C# in Visual Studio. But there are certain libraries which are specific to ANSYS. The Visual Studio do not recognize this by default, so we have to reference this to Visual Studio. Alright, so we need to reference these libraries to Visual Studio. These libraries are specific to ANSYS. So to add these references, come to Solution Explorer, References, right click on References, order. This is how it's going to look, blank. So these DLLs are available in ANSYS installation location. Here is the installation location. So browse to that, and we need wb1.dll, which is going to call the mechanical interface stuff. Let's say okay. Now save this project. As you see that as we started adding the libraries, these lines start disappear. So we need one more for user object. Let's try to add one more library. Browse, which is going to be interfaces. Okay. Okay, so the interface is available in interfaces library. Now I really want to highlight some of the syntax issues in the example given in the help manual of version 18.0. Let's start looking at this. This is called constructor method. For this to work, there are certain syntaxing that we need to follow. Okay. In this example given here, the syntax is not correct. So let me show how to identify where the syntax is not correct. Then I will show you how to correct this. Okay. So wherever you see the red color underlining, those are all the areas where something is going wrong here. Okay, let's try to build this to make the DLL. To build the DLL, go to build and say build C#1. That's the name. So it says that the method must have a return type which corresponds to line number 12. There is some issue in this line. So what it means is that there is a syntax error. So this is the class name load. This and this construction method name must be the same. So there are two possibilities. Either you can change the class name as custom load object controller, or you can change the custom object controller as load. The class is the one which will be called from the XML. Now if you look at the XML is calling a class called C#, that's the namespace, and here is the class name .load. So if we are going to change the load as custom load object controller, then this should also be changed as custom load object controller. Okay, there are two ways. Let me show the simplest way here. Load, and let me make this as load. and this is also consistent with this. And make sure CSharp is case sensitive. If you are using capital L here, we have to use capital L everywhere. Okay. So with this we can clean up the previous errors and try to rebuild, and let's see what happens. It says namespace IEXT API doesn't exist. Okay. Let's see whether this namespace exists in mechanical. So how do we check? Go to help manual and quickly search for this ext API. There is no reference for this particular namespace except in this example. So it indicates that there is something wrong. Looking at the syntax, this supposed to be iMechanical ext API. So there is a typo error. Okay, so when we change this to iMechanical API and try to rebuild this again, that error disappeared. So this error disappeared, and this return for this construction function disappeared. There are issues with IMS data. What it means is that it says that when you place your cursor over there, that the type or the namespace IMS data is not found. What it means is that these two libraries not containing this IMS data namespace. So how can we check? If you double click on references or ACT interfaces, it will show these are all the libraries that this class.cs can access. Now let's see, is this namespace available here? Okay, you can check this. Okay, it says it is there in the interface iMesh data, but however it's not accessing that. So what we could do is we could reference this one more time. So odd references, let's browse here. Let's see, is there any option for this? ACT Workbench DLL that we have already added. Okay, let's reference this here. Then it's already existing here, but it could not call. Okay, so what we can do is that we can externally reference this one more time, interface dot mesh. So the moment we add this error start disappearing. Okay, all right, let's try to go and rebuild again. So now it's almost clean except one error, that's math is not there. If you look at the original syntax, the default syntax that was given by Visual Studio, we had something called a system. This system library is going to contain all the math operations, so that's not been referenced here. Probably we can include those library as well here, the system library. The moment we include the system library and save this project, we should be able to clean up and build the C# code. Now it's successful, there is no more error. So our DLL is available here. We can copy this DLL. We can copy the DLL from here. It will generate many files. So what is of our interest is the assembly or the class name namespace.dll. Okay, that's the name what we have given originally there. So we have to bring this back to this example, so which has a XML file and C#. Inside that we are going to place this CSharp.dll. We have to make sure the name is consistent in XML. So this is supposed to be CSharp.dll, not CSharp1.dll. Okay. So let's rename this CSharp.dll. So typically when you build app based on based on based on okay, let's go back here. Let's go back here. Yeah, when we build, there will be a XML file and a folder, then there will be a Python file and the image. But in case of C# approach, it should be a DLL file plus the XML file. Okay, so now we have all the setups done. So we need to load this extension into Workbench. So this is version 18. So let's start page, extension manager. So we need to add this file. Example1 is the place where we are going to where we kept our files required for building this ACT. So add this folder here, and C# is the okay, sorry, it should be example1. Okay, open sorry, yeah, add folder. So it was in D program C# example. This is the location. So the moment we reference to that folder which contains the XML file and the DLL file, that get ordered. So it's loaded now. Can come back to the project page and manage extension. So this C# is included in this project. Let's see whether we can use this in a project. So add a static structural system. We need a dummy geometry. I'm just going to browse some dummy geometry here. Okay, so there are some warning messages. Let's see whether the C# load is appearing here. Okay, so this is the custom item that we have created. Okay, let's see whether we can insert that C# load. Let's choose a face here, this face. Okay, so in order to evaluate this, we need to do a dummy solution. Let's say this end is fixed, and we're going to apply some dummy load. My intention is not to solve this problem correctly, only to demonstrate the procedure to build the ACT app. Okay, so once this is done, we can solve this problem. It's going to take very quick time. So let's look at what is this ACT is doing. So what is this ACT is doing is it's just calculating the distance or the location. So again, my intention is not to build some specific action using this program, just to demonstrate that. Okay. So once this is done, and we can go and look at that. Okay, the C load is showing the demonstration. So basically this is this geometry. If you check, it's 0.1 meter length, so it's showing that the variation is at the 0.1. Okay, we could add multiple loads like this. Say insert C# load. Probably you can apply on this face. Okay, and just say solve this again, and you can see the variation. See, look at this and how it varies. You can switch off based on the location. It shows the different stuff. Okay, so this is the typical procedures to build an ACT app using C#